We're recording.
So I'll call. Okay, call the meeting to order. It's 10 o'clock now. Looks like everybody knows everybody, so we'll skip introductions. Minutes. Has everybody had a chance to look at the meeting, the minutes from last month? Any changes?
I make a motion to accept the minutes as entered.
I second the motion.
Second. Shh. Don't see any hands up. So
All right,
approved.
Wayne, you cut out. Sorry.
Yeah, I don't know. It could be this way. Today is like what a couple of months ago. Remember a couple of months ago, my audio just kept on cut out, my video cut out. Looks like I got another weekend of that. I don't know why. It just comes and goes that way. Okay, treasure report. Eric told me to be gone today. Whoops, I bumped something. So I have the treasure report here. He told me that the balance is the same. No money came in, no money came out. And the statement I have here for last month says we have $2,357.18. Getting some noise from somewhere.
I got a note from Eric that's different than what you said, Wayne.
Okay. This is the last statement. What do you have?
Here's what he says. I will not be able to attend the meeting this weekend. There has been no change to the club books. Total is still $2,407.18.
Okay, yeah, I see that here. 3.1. It has that's a other line on here, which gets $2,407.18. What you just said.
Yep.
On 3.5. Okay.
He also said that he did send a thank you note to Keith Lord, the NA0T, for the donation that he made.
Make a motion to accept the treasurer's report as read by Bill KUG. Or sorry.
Second the motion.
DX.
Again. All in favor, raise your hands. So moved. Okay, trustees report.
I have no new business to report.
Can you put a little closer to my mouth? Can you put a little closer to talk?
Hello.
Go, Jim.
Say it again, Jim.
Better.
Yeah, I have no new business of trustee nature.
Okay, thank you, Jim.
Jim, I think you might have a loose wire in your microphone too, because it seems to make noise like it's brushing up against something. So I'm not sure.
Well, I'll refrain from singing, but how's it doing now?
That sounds better. I don't think we're hearing it now. So
I'll hold it more carefully.
I use the word
digitally.
wonderful.
Okay, technical report. As far as I know, all the computers are working. We have one slight issue with the fusion part of the 7 centimeter that Nick is working on. But otherwise, the computers all themselves are all working. Anybody else have any comments or any observations?
Yeah, well, Eric's
Hold on a sec, let me comment. May I comment on 2 meters? I have both the analog and the digital radios on beside me roughly 2 and 3 hours a day. Occasionally, people will go the digital one, and I could talk to him. So I guess I got the hang of that. But back on our analogs, I haven't heard and I put out calls. I put out a call once, twice a day, and I get nobody back. So our 2 meters are pretty quiet these days. Okay, that's the comment from N0.
Bill, you had something?
No, just that in the note that Eric sent, he said, Nick has fixed the computer side of the repeaters. They were working on Fusion Tuesday evening. Did they have to go up to the apartment building site, or could he do that from home?
Fusion side of it is at his house. The repeaters themselves are all working. The fusion of it, it does 2 meter, 7 centimeters, still has no cable yet. You know, one of his computers, the porting on it is causing intermittent problems. It works sometimes, sometimes it doesn't. That's just the fusion side of it. The analog side on both repeaters all work.
Okay, all right. Well, that makes sense.
So Nick's working on the 7 centimeter now. He got the 2 meter one working. I talked to him just the other day on the phone. Okay, do we have any? This guy, my internet's unstable again. Do we have any old business to bring up? Okay, new business?
WHR,
Go ahead, Wayne.
I guess this would be new, basically this afternoon at, starting at 5:30 to 8:30. KC4 USV is going to be on the air, 14243 for sideband and 14070 for FT8. So if you need the Antarctic, this is your chance to get.
Can you repeat that for me again, Wayne?
Yeah, it's 14.243 for sideband and 14070 for FT8. And it'll be between 5:30 and 8:30 tonight. It's going to be on. And if you are all that ambitious and like Wayne, tomorrow, or at least April 18th, midnight to 2 a.m., they'll be on sideband.
Okay, the call sign was what again?
King Charlie 4, United Sierra Victor.
Okay, thanks, Wayne.
You're welcome.
There's a short paragraph in the open mic to that effect. Over.
Yeah. Okay, one thing I had was, in August, we have a pay, and with the COVID thing going on, all the virus stuff, it's hard to say what's going to happen at that point. Hopefully by then things will have settled down, but what are people's thought about the picnic for this year?
I'm going to leave this up to the older members to make that decision. Be honest with you, I have not had the shot, and I work in an office without a mask with a bunch of law enforcement. So my exposure is pretty high. So if you don't want me there, that's fine. Yeah, that's the way I feel sometimes. Yes, thanks,
Yeah,
Jim.
Laura and I have both had the shot. Lori and I have both had the shot, and we both wear masks. In fact, I carry them in my car, I carry them in my truck, I carry them. We got X masks all over the place.
I guess I would suggest that we forego the picnic this year. Just because, I mean, we do have a lot of us old timers. Yes, I have had the shot, but I stay away from restaurants. I stay away from crowds of people. And I mean, we'd be outside and everything, but I think basically we should stay cautious and just.
Okay.
I think
kinda
we should do just a 1 hour event, of just on the air. How about that? We just pick a time and just do 1 hour of just reg chewing.
Could do that.
Sounds good to me.
Where would you like to meet then?
Because we could
2
do
meter
a Zoom,
HF?
have a Zoom set up and do the reg chew.
Okay.
So, and it doesn't have to be an hour. I know somebody don't care to listen to half of us.
Yeah.
But,
I suppose, I suppose picking up on George's point, we could exercise that 2 meter repeater in, Alex. Anybody in the group
I
that
know
cannot?
Eric
that
and I have
cannot-
been on a few times.
Say again, Wayne?
Anybody cannot get on to, I'll say Eric and I have been on the 2 meter radio a few times. I've talked to George a couple of times in 2 meters. So it does get used, but it does not get used very much. Be a good time to use it.
The beauty of the 2 meter analog is FM. And I can generally hear quite well 2 meter FM. Over.
It might be kind of a long stretch for Tom to get in then.
Well,
Oh, he'll
Tom
have-
can
he'll-
get that amplifier up. He probably would be able to reach it. He's up
Yeah,
on a hill anyways.
He'll have that half a K amplifier going by then anyway.
I don't have any problem reaching Alexandria even with 15 watts.
Okay, that sounds good. I know you're out there a ways. I wasn't sure if you can make it or not. So it looks like everyone could make 2 meters then, from the looks of it.
I
Sounds
can
good.
do 2 meters.
Say again, OVN?
I can utilize 2 meters.
Good. And to this virtual picnic, should we bring hot dogs, potato chips, and beer, or what?
Absolutely. There's no question about that. I mean, you also have to bring, you have to share what your special beer is.
I
Mine
ain't
is in a
sharing.
red can.
I ain't sharing my beer with nobody.
No, the label, black and white labels are
Oh,
not allowed.
I misunderstood. Sorry.
Yeah.
Or in Wayne, you
we
can
can-
bring up your glass of wine, but you got to keep the bottle.
I've switched to beer.
Okay, there we go. There we go. So potato chips and beer. Here we go, virtually.
And Wayne, no more of your oddball label beer.
Oh, I got some very oddball labels.
Hey, Wayne,
Yeah.
I got some Fat Tire if you like that.
No.
Oh, you don't like the Belgian beers?
Oh, yes, I do, but that's okay. I got others.
There might even be some.
I've got some hard cider that I've got to fill.
Even a little homebrew will work.
I can get that out of down in Iowa.
Okay, sounds good. So we'll have the club meeting at the next regular meeting then in August. Is everybody's plan?
I suppose we could, sure.
I'll put that down. There.
Wayne, you cut out. Hopefully you're coming back.
Okay. Okay. Third Saturday, we'll have the picnic in August then. Sound good to everybody?
Yep.
Works
Good.
for me.
Okay.
And do it via 2 meter?
And we'll do it via 2 meter and
2 meter and Zoom. There
And
we
Zoom.
go.
Yep. We're gonna have to be quick on the muting of our microphones.
I have to wear my
End up turning off the microphones.
the microphone will pick up my radio then.
We can turn off the microphone as far as for the computer and use the audio from 2 meters.
That's true. Good point, Wayne.
And
then
we
by-
can also do a simplex relay test too.
Yeah,
A simplex relay?
Yep. We'll just basically have everybody switch over to the output side of the repeater and just start doing check-ins, and those that can hear them can relay who they heard.
that would be interesting.
Yeah,
Okay.
wouldn't it? Oh, wait a minute here. We got people who have Yesus. That's not the easiest side to flip over to. We might go, maybe we should think about maybe doing it on the call frequency of 52, but that might be a little bit easier than, because I know it's not so bad if you can program your Yesu to do it and just have it so you just change to it. But trying to get through those menus sometimes is a nightmare.
I
On
vote
mine, it's just a
for-
push a button.
I vote for 146.52 or 146.46. Yes, I vote for simplex frequencies. Over.
I'll tell you what, I'll do an ICS 205, send it out to everybody, and then we can, then we'll go from there. We know which ones we'll be able to go to and make sure you have them in your radio.
I can do both at the same time, so
Yeah, you got a Kenwood.
no, I got a Kenwood and Yasu both. Each. Okay, sounds good. With Skywarn, weather watching.
Sorry, Wayne, you cut out a little bit there. What was that?
Okay, the Skywarn, weather watching. Is anybody interested in doing that this year? I know I'm signed up with Chen Hansett right now. Is anybody else or Todd County or?
Yeah, I see Jim is. You're going to be doing for Pope County then.
Okay.
Tom, I'm assuming you'll be, whenever you're there, you'll be doing Morrison.
Right, I'll be doing Morrison County when it looks like we're going to get activated. I start monitoring Stearns County. And do you have anything going on with Todd County on 2 meters?
No, not that I'm aware of, because the bulk of mine is I have to have my seat sitting in the dispatch at the number one position and kind of directing the show. So that's my orders from here. So unless Rick Bile does something up with the Wadena Club, which I think they do, but I'm not totally aware of what they do.
Anybody have a status report on what Stearns County is doing with regard to Skywarn?
Nope.
Last I
don't
heard,
either.
they were trying to revive it, but it hadn't gone well.
I shouldn't say this, so I'll keep my mouth shut.
But as always, you can always spot and report into the National Weather Service, because as an emergency manager, I can tell you it's very helpful to know what's coming at us.
Speaking of Stearns County, has anybody checked into the hospital net lately?
I
I
haven't
have.
I have not from my home, and the hospital won't let me in the building.
And I have heard it, so I think it's been running, but I don't think it's been fully supported.
Which is kind of ridiculous because it's in times like these when it should be supported.
Okay, that's all I had for notes this month. Anybody else new interest in the club?
EBZ,
Ed Wayne.
here's the club analyzer, and it does 2 meters, but does not do 440. The previous one we had did 440, but that's the one that became corroded and totally shot. I think Richard tried to revive it and it was non-revivable, so it was thrown. And this one came from John Hoven and donated to the club. And basically this one goes up through 170 megahertz. So that's the answer to the question you had earlier.
I used that a couple of years ago and it works very well on 2 meters. And just a question of how I can get my hands on it. I'm not in any big rush.
Well, also remember that we have a one of those fancy watt meters. Can't remember what it is anymore.
That's a bird.
Yeah, I was
Bird.
gonna say, isn't
There
that
we
the
go,
bird?
the bird. I didn't want to bring that up because I would be just, I mean, that's not nice. But anyways, we have the bird, and that one, I mean, we were told that it did not work for certain slugs or anything. I've checked the whole thing out and it works perfect. So that's also available to do fine analysis.
If we ever do a face-to-face, I'd like to get my hands on it.
That sounds good. I'd like to get my radio back
Good.
also that I loaned out 2 years ago.
Appreciate it.
Yeah, have you heard from them? Okay. All right, I'll second the motion to close the meeting.
Okay, do you have you have a second? We got first.
I
Wayne,
make a
wasn't that you?
motion.
Motion hasn't been made yet, so. Okay.
I'll make the
Motion been
motion.
made. Mike seconded it. Mike made motion. Mike seconded it. Approved. Raise your hands. So moved. And Bill. DX.
Yeah.
Thanks for putting all the information on your newsletter about all the upcoming events.
Yeah, there's no shortage of things to do if you want to get involved.
Yeah, I was reading through that. There's quite a list you put in there. Thanks for doing that.
You bet.
Okay, meetings. Mike,
I
it's
guess
yours.
we probably should point out that today and tomorrow is National or World Amateur Radio Day. So it's a good thing to get on. Just
All
Google,
right.
just Google World Amateur Radio Day. And I guess it's up to Mike.
Yeah, there's a ton of events going on, and being in nice weather, you got POTA and SOTA also going on. So,
Have a nice weekend, everybody. I'm going to take advantage of the good weather.
all right.
I gotta go do some other stuff too, so I'll check in on the video later.
Sounds good. See you guys later. All right. Just bear with me. I'm kind of getting my screen prepped up here so that I can actually see what's going on. Okay. So everybody should be seeing my screen. Today's presentation is on end-fed half-wave antennas, or EFHW stands for half-wave, or end-fed half-wave antenna. It's a variation of a dipole. And the interesting part is the rules don't say that a dipole has to be fed from the middle or even offset. It could be fed from the end. And we'll kind of, later on, I have a video that shows the performance of it and comparing it to a dipole. And then reality is they're exactly the same. It's just a different way of setting it up. So there's changes in the impedance. So there's a big difference in impedance of the antenna. From a center fed basically is 72 ohms. For an end fed, it's anywhere between 1800 to 5000 ohms. So there's quite a big difference in that. So what you're trying to do is bring that under control. The current and voltage change within the half wave, as you can see from the diagram, shows you kind of the distribution. So based on the length and the resonant frequency, the standing wave develops on it. The standing wave consists of both current and voltage that are 90 degrees out of phase. And in the end results is a distribution of current that is at a maximum at the center of the distribution of voltage. So basically, if your half wave antenna, you can see that your current and your voltage are within even and trying to match at the center. So why did I want to make a end-fed half-wave antenna? Well, I plan on actually doing this year a POTA activation, or Parks on the Air. Also, there's a number of SOTA, or Summits on the Air activators that backpack quite a few miles into and up to summits and need something light and simple to erect to make contacts. They also needed to be able to break down and pack away easily. Same with POTA. You know, if I go to a park, I want to be able to set up and take it down. But it also comes down to is you're basically doing the similar thing with radar ops, or rapid deployment amateur radio operations. So you need an antenna that you don't have to send there. You know how many times at field day we've spent time trying to put it together, and then I forget to hook the coax up, and then we got to take it all down again, or we get it up, and it could take up to a good hour because we've got so much help sometimes, and that's just the bulk of the work that has to be done. And this kind of eliminates that, because in a lot of cases, if you're doing POTA and SOTA or radar, you're doing your ops by yourself. So you need a quick way to take up and take down and get out of there. So including emergency operations. Some of the places that you'll be setting up are going to be limited to real estate. You're not going to have a lot of space to be putting a really long wire out there. So a half wave antenna is a great thing. No tuner needed. And we'll discuss making what a multi-band antenna looks like, or how you can make it. But the option of having to carry that extra weight of a tuner is eliminated with the end-fed and with this transformer that we'll be discussing. As I said before, rapid deployment and demob. weight and collapsibility and size. This will be transported in a backpack along with a radio, a battery. So, and any cables and possibly a key. So you got to have weight considerations in there. Now, of course, the ones that I've made are a little bit heavy, but they are able to take a full 100 watts. There are many out there that you could build that are for QRP or QRPP. So it's just one of those things that that some of the SOTA users actually do QRP and have a very, very small transformer and wire antennas. So what we're going to be talking about is a parts for an antenna system, but it's a 49-to-1 onion. And an onion is an unbalanced to unbalanced transformer, half wave of wire, and end supported. So the transformer end is usually fairly close to the ground. And we'll talk about grounding and all that, but it is not reliant on having radials at the base of the antenna. And you'll be amazed on how well it performs. I just kind of put the parts list here. And one of the things that and this is, I should have corrected this. I did not. 2 cores actually can take you up to about 500 watts. 3 cores of toroids will take you up to the legal limit. And it also depends on the wire you used. I used 18 gauge enamel wire, and I will tell you it is very fun to try to bend that wire. You'll also need some capacitors. So you can either get by with 100 or 110 picofarad, 15 kilovolt. Some have built them with 6 kilovolt, but the instructions that I will be showing you here in a minute recommended 15 kilovolts or 2 in series 22 picofarads. And as we may not be aware of, those that are not familiar, I'm sorry, those that are not familiar with the formula for calculating it out, basically if you put capacitors in series, this actually becomes 110 picofarads. But it gives it 15 kilovolts. The capacitors are more critical in the higher bands for helping flatten the SWR, and I'll explain to that in a little bit. And 18 gauge enamel or magnet wire. Depends on what school you come from. I call it enameled wire. I think the old timers all call it magnetic wire, but either way, it's I think either way it's interchangeable. Magnetic, I think, comes from windings of motors and generators, I believe. You'll need a box. Good old Home Depot. There's going to be a box that you can get there. Then DigiPan. So I did a UHF, and I'll talk about this later. I did an N-type connector, panel connector. You can do BNC. So it's all kind of dependent on where or how you're going to use it out. If it's going to be outdoors all the time, if it's not, or if you're just going to take it along. BNC connectors are lighter, but you can always use any type of 50 ohm connector that you need there. And then I just kind of give a list of the screws that you're going to need to assemble this. Stainless steel eyelets. Good luck on finding those. I ended up having to go with a zinc coated one because I couldn't find any stainless steel ones. But it still works, and it still hold up to the weather. Ring wire connectors. So these are basically your bolt type connectors that go on the end of the wires, and I'll kind of point them out. Cable tie downs and silicone sealant.
Mike?
Yeah.
I just wanted to mention that for the stainless steel eyelets, you might be able to go to a marine source.
Yep.
Because a lot of the fittings there are stainless steel.
True stainless steel too, right? Yeah, thank you. That's a good point. Yeah, you can get those stainless through the marine outlets. So one of the things is the recommendation of using a particular toroid mix. You can either use a 52 toroid versus a 43. You can, if you go to this website here, you can see the difference on them. Basically what they are is the bandwidth transformer frequency. Oops, sorry. So the transformer frequency, the size, and everything else. So I used 240, so that's basically it's 2.4 inches in diameter, outside diameter, and it has a mix of 43. The mix of 52, if I remember, it gives a transformer range up to 500 megahertz, I believe, if I remember right, and it drops down to 3. So it's got a little bit farther broader band, but I didn't need that. But it is also a little bit more expensive for some silly reason. It's probably just how much they mix into the material. But here at this website that I mentioned, you will also get calculators that are available at the bottom of the screen. So you can actually calculate out the windings and everything else if you're trying to make other types of transformers. So starting out with construction, basically I just used a CA glue, which was a lot faster than using my 6,000. With 6,000 takes 24 hours to basically dry. But if you, with the CA, all you're trying to do is you're just trying to hold those together, so while you're wrapping, the cores aren't sliding all over the place on you. So they basically ended up putting like 4 little spots onto so I put a spot here, a spot here, a spot here, and a spot here. So, and then I just put them together so that they stay in place. Then, now you'll see mixed reviews on this. Wrapped it in Teflon tape. This is the first time I did it with Teflon tape, and I probably will not do that again. The Teflon tape didn't hold up as well as I thought it should. But it's basically trying to protect the enamel wire, so when you're bending it, these edges here are not chipping away at the enamel, so you have some arcing going on. So it didn't do what I expected it to do. The first one that I built, I actually only used I was using a little bit smaller wire. I believe I was using 16 gauge wire on that. No, what was I using? I think I was using 18 actually. So anyways, it just kind of this is kind of a protection for the enameled wire, so you're not scarring the coating, the enamel coating off. So that's what the Teflon tape is there. You can use electrical tape. And I will tell you, it is so fun to have to wrap one of these, but it does give you a little protection so you don't damage the wire when you're winding it.
Mike,
Yeah.
When that Teflon tape for plumbers, is that the same stuff they use on a threaded pipe to seal it?
Yep.
Okay,
Yeah, it's just regular plumber's Teflon tape.
very
And
thin.
Yep, it's very thin, and I didn't realize how thin it was, and I think you'll see it in the pictures here when I get down to winding the transformer. You'll see some areas where it kind of opened it up a little bit, but I didn't see any issues on the enamel, but it probably provided a little protection. So the next item that I did is I have these connectors, and my original one I used the original adhesive that came with them. Don't do that. Peel that garbage off. It didn't hold up. It pulled right off of there. So what I did is I took it off, and then I just used CA glue and glued it right down. I put the transformer on top just to kind of get a distance, make sure that when I run a zip tie through here, that it holds the transformer inside the box. Now, as you can see, I haven't drilled any holes in here yet, and I didn't quite get into those kind of details because that's all kind of going to be dependent on how you want to set your box up. So these instructions here are actually pretty good instructions once you kind of get through and try to figure them out. But so here is, so we have primary winding that has 2 turns, secondary has 14 turns. And so what they're referring to is the primary is the red one here, and the secondary is the blue. And I will go through and it kind of explain a little bit. Now I'm going to show you a video. So the high powered one that I just built is 18 gauge, or I'm sorry, 14 gauge wire. The 18 gauge is what I built on my one that I'm running 100 watts through. I am using two 2200 picofarad 1500 kV, bought them off of Amazon. They're cheap, and hopefully they don't have to send them from the slow boat from China. But if you look up K1TA, you can also get this information, and it's really good. It also talks about using 1, 2, or 3 cores depending on the transmitter output to be used. I have built a 2-core is the original one that, like I said, I'm going to take with me when I activate POTA. And I just finished building, and this is the one that you were looking at, just finished building the transformer for here at the house. Actually, I was and I'm going to kind of experiment off of it, and I'll talk about antenna wires and everything once we get down to that point. It gives you a primary wire about 13 inches and a secondary wire about 80 inches long. And of course, 1 and 2 cores use less wire, but this is for the 3 cores. So it kind of gives you a hint of how long the wires should be, or the wires should be cut at. So as I said, you're going to cut your primary at about 13 inches of enamel wire for the primary winding, and you're going to cut 80 inches for the enamel wire for secondary winding. Twist the primary and secondary wires together. Be neat about it. This is one of those things, is it doesn't it should be neat because you're because of the way that it's actively affecting the magnetic field around the wires, because they are twisted together. What you're after when I say be neat is try to be as consistent as possible in the lengths of the windings when you twist the wires together. One, it makes it a lot easier than when you go to try to wrap it and put it onto the core. So what I'm going to do is I'm going to show a video, and here's the link to it, the YouTube video, but I've downloaded it, and showing how Steve Ellington has done his, and I'm going to kind of, when he gets to the winding, I'm going to kind of bop in there and talk a little bit about how to count your windings, because the way he does it is not kind of the way that a lot do it. And Wayne, I'm going to let you come in too, because and give your opinion, but for counting the windings, that's where I'll talk in. But let's get into this video. Let me know if you can't hear anything.
So anyway, first thing to do is take those two pieces of wire, and we're just going to twist them together here like so.
This is the primary
and make
and
us a braid.
secondary is being wound together.
And this takes a little bit of time. I've had people tell me that this twisting needs to be done nice and tight. And that insulation on this wire is pretty good. You don't have to worry about it shorting out. And if you did worry about it, it wouldn't do any good anyway. So I'm pulling and twisting, and I just keep on till I get almost to the end. And whatever we don't need, we'll just cut it off. Almost there. It's not perfect, but it doesn't make any difference.
Yeah, and
I haven't tried
this is where I
doing
was
this,
talking about. It's
building
just
one of these without
consistency, just
twisting it.
trying to have a consistent
Who
wind
knows,
on
it
it.
may not make any difference.
And his
Now,
winding looks a lot better than mine did.
I think that is probably,
And 14
gonna
gauge
do it
wire
right
is fun
there.
to try to do
so
because it's so stiff.
I'm going to take it out of the vise. Now, this end here, this is going to be ground, and it's going to go to the ground terminal of the SO239 connector and to our ground lug. All right, this end is going to be the beginning of the secondary. This is going to be our secondary right here. That's what that 7 feet of wire is for. So here's our core. I took 3 of these things. They're $4 a piece. Don't worry about the $4. Just go ahead and get 3 of them. This can handle a couple of kW sideband very easily. And all I did was put a dab, about 4 dabs of super glue around it, put them together and let them set a while, and they're stuck together very well. So what we're going to do, I'll stick this through the core, and I'm going to bring it around to about the halfway point.
Okay, when he's talking about halfway point, he's talking about doing it from right here, so halfway between the side. So that's something that doesn't quite get explained very well sometimes. Is your halfway point is here,
right there. See, as so. All right, and we're going to go ahead and wrap this around again, this primary. Okay, and then we're going to stuff it up through the bottom like so, and bring it
kind of
around.
see what I was talking about is because you're rubbing up against the outside of the core. when you're trying to pull it through, because you're
Pull it
trying to
good and
keep
tight.
it as tight as possible and without
And
air
right
gaps
there.
on both sides. So you can see he
There
did
we
halfway.
go. Now,
He went halfway here. And this angle, of course, doesn't show up, but he went halfway here. So one of the things he's going to refer to is talking about is reading the number of turns from the side. And I would not recommend it. If you're going to do the number of turns, which is supposed to be 2 turns, do it from the top. So as you can see, 1 and 2. It just seems to be the way that the winding of the instructions are that seem to work out the best.
that is 2 turns. And we count them like this. Now here's where we started right here. We go around, and that's turn number 1. And then we go around again, and there's the end of turn number 2.
And this is where I was talking about is because it'll be confusing because you're actually going to do a crossover turn, and you'll see it.
Try to get this all on the camera the best I can here. So you start here, and every time you reach this point, that's a turn. And you go back around again, there's another turn. So that's the conclusion of the primary. And again, this is your ground. All this is leftover, so we can trim this however we see fit. Okay, the other end here, this little job, this is going to go to the center pin of your coax connector, your SO239. That's where your power goes in, right there. Okay, now we're going to take this. We're going to build the secondary. We're just going to continue around here and back down through the middle. All right, one, we'll go there. We're going to get about 7 turns out of this on this side of the core. And do it again. And then again. See how easy this is? Really, you can't go wrong. Yeah, this is 14 gauge wire. It's not too bad. I tried 12 and it was just way too stiff. I didn't like it at all. I don't think it's necessary. Might even be able to get by with 16. Let's stick it through here again. And now when you count the turns for the secondary, remember that our secondary and primary are wrapped together, so we've got to count it all. So remember this was our first turn right here. 1, start here, go around, that's 1, 2, 3, 4, 5. Let's do 2 more. 1, right there. You got to kind of squeeze them in there as you go. Yeah, it's better to have them close to the core when you do this. If you want to take your time when you're doing it and do a little neater job, that's fine. But anyway, all right, let's see what we got here. We got 1, 2, 3, 4, 5, 6,
So
7.
like I was saying, it'd be easier to count from the top. 1, 2, 3, 4, 5, 6, 7. And he's working on the 8th one right here. So, and you'll see what's going to happen here.
And what we do here is come out the bottom. We don't go back around again. And we're going to go over across the bottom. See how I did this?
And that's number 8
All right.
going across.
So now I'm starting again. This counts as a turn. That cross across there was number 7 because it went down through the middle of the
Actually,
floor.
it's number 8, but we won't correct them.
Count that as a turn. All right. All right. There we go. So that's 7 turns. And we just went around again. There's 8. Nine. Number 10. Number 11. 12. Sloppy work there, Steve. 13. Okay. Now, the ones I've seen built stop right there, and they come up like this, and they go over to the antenna outputs. I've really got 13 turns here. And it seems to be inconsistent, what I have found. And I can go ahead and put the last turn in and then come up here like this. Now that'll give me 14 turns, which is a 1-to-7 ratio. I've seen it both ways. But anyway, let's count them again. Here's the beginning. 1, 2, 3, 4, 5, 6, 7.
So if we actually take a look at it from the top, 1, 2, 3, 4, 5, 6, 7, 8 is what comes across. And that would be more consistent with the winding instructions that I shared in the previous slide. So I just kind of wanted to say it is definitely easier to do it from the top than trying to figure out, okay, you're doing halfway through, because technically when you're going across, you're not doing halfway through. So it's easier to count from the top than it is to try to count from half through the sides. Also on this final antenna right here, this final wire that goes to your antenna is as I do it about half, and that's basically what he did too. It's about half point. And sometimes they say it's easier also to take it, maybe zip tie these as you're winding them so they don't kind of come apart on you, but it's kind of up to you. With this stiff a wire, I had no issues of it coming apart on me.
8, 9, 10, 11, 12, 13, 14. So I've got more than 14 turns doing it this way. So what people do is they kind of come up like this, and then about the halfway point or somewhere, they'll bend it over and go out to the antenna port. Now again, that's kind of a sloppy job because I didn't take the time to smash all this wire in there. But I hope you can see. Let me turn the camera around here at a different angle. the light might be a
So,
little
and
better.
Wayne, you had a question when we talked about this before, and as you can see, the spacing, he's actually got pretty tight spacing. I kind of spread it out, use it a little bit more, but it seems to either way, as long as they're not touching, that seems to be okay, and it doesn't seem to affect anything. They still have the same responsiveness.
You see that crossover on the bottom? So let's see.
All right.
And this is our.
We'll just move on. So here is my spider. Because believe it or not, when I was putting the slide together, the AI was actually identifying this as a spider, but this is my wrapped coil. As you can see, when I was talking about here, is that Teflon tape provided a little protection, but as you can see, I kind of peeled a little bit of it away. And so, in this enamel, I did notice it did crack off a little bit, which is fine on this piece. But my biggest concern was when I was wrapping it that it didn't do anything else. So you see a little bit on the inside where it kind of peeled away. But all in all, I think it provided enough protection. And as you can see, the wires is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So yeah, so you can see that this is 8, 9, 10, 11, 12, 13, 14. So by counting it from the top, it makes it a little bit easier. Any questions? All right, I'll keep moving on then. So basically the final, Mike. Yeah.
Okay. Wire there, or the enamel wire there. Could you use Teflon wire or MTW wire instead?
You can. The only thing that that I've heard is the biggest thing is the air gaps. As you saw, Steve had quite a bit of air gaps in and around this spot right here, and they just don't want as much air gap. I mean, it seems to have an effect if there's too much air gap in there. Is what I've gotten. So yeah, if it's a very thin, maybe you could probably get by with it. I would say. I mean, as we all know, RF travels on the skin anyways, so it just kind of creates that distance gap in there. And I don't know, I have not done it, and I have not seen it done that way, but I would say it should work. I don't see why it wouldn't.
Yeah. The thing is 16 gauge stranded wire instead of solid wire, Teflon coated, it would be softer, easier to flex, wrap around.
Yeah, but it might also not be able to form it when you come around either. I don't know. It would be interesting if you want to build one, because it would be interesting to see if it'll form to the outside and stay there, or create that air gap in there.
Okay,
all right, so here is my box. So what I did is I have an N-type connector here. Here's my ground. You can see my ground lug going here. Here's the capacitors that are going, basically the capacitor is going from the feed point of the center pin of the antenna connector and feeding right over into the ground lug. The antenna, as you see, is coming out. So the antenna spot is right here. I was concerned when I put this eyelet in, if it was going to affect the antenna SWR. Good news, it did not. It's interesting. I thought it would, but because I'm basically, this wire is coming right past it, but it does not seem to have that effect. And coming across the other wire, it's not really that big of an effect. So I was prepared if I had to slide stuff back down and around, but I did not have to. It all seemed to worked out. So, you know, it's basically drilling holes into the box and putting in. I ended up, when I started the instructions, I had number 6 32 screws in here. Hint, they only make the holes for 4 32. So I ended up drilling them out, cheating a little bit, but at least they got a bigger contact. I also used nylon locking nuts, and the reason why is I didn't want them vibrating loose. I also did them on the outside on the lug nuts, so the ground lug, so it's actually attached, and the eyelets are in here. So if I ever have to, I can basically fairly simply dismantle this, unsolder this point right here, and take the coil out if I have to replace it or change it out, or if I do something, want to do something crazy different in there, I don't know. Maybe change capacitors, who knows? But at this point, it's been pretty good shape. So, like I said, originally you can use an SO259, you can use an N type or a B and C connector. It's all up to you what you want to do. I used the N type on this particular project box, and the reason I did that is the fact that this will be outside. So this is a utility box for electrical, and so it has a rubber gasket on the lid. So that way it'll keep the water from getting inside. And then the silicone, basically what I'm going to do is I put silicone around each one of these on the outside. It's just kind of give it a little extra. You don't probably have to do it, but I'm just doing it just to case the plastic decides to shrink a little bit or something later on in life, if it's out in the sun, that it doesn't start leaking and putting water inside there or moisture. So the testing. So I actually hooked this up to my analyzer, and to test them. Basically, the recommendation was basically hook up a 2500 ohm resistor, which I did a 1000 and a 15 or 1500 ohm resistor in series, connected to the antenna port and connected directly to the ground, put the analyzer on the end. And at 80 meters, I literally had a 1.1 to 1 ratio. So, and as I went swiping the entire band, it didn't move more than 1.2. Then when I moved up through the bands, the highest that I ended up getting was, and I believe it was at 10 meters. Don't hold me to it. I believe at 10 meters, I was getting something like 1.6 and sweep that band, and it was still fine. So, and of course, as we all know, it's all going to come down to harmonics, and well, we'll get into that in a little bit too, but it still kept the SWR down pretty good. And I'm going to kind of show you some charts. They're not charts that I've done, but they're done with testing this end-fed antenna in different configurations. So that's pretty much the assembly piece of it. I mean, it's the assembly and testing of it. It took a while because there's not a lot of people who talk about how do you test this thing. And you know that you're trying to hit. So it's going to be anywhere between 2,000 and 8,000 ohm wire that's going to be sitting out there. So how do you test something like that? And being that it's a 49 to 1, basically is 2450 for ohms is what you're looking at. Well, go to, you know, as we all know, the resistors, even these are 1% resistors that these are 1 watt resistors. They're 1%, I believe. Maybe not. I guess I didn't. No, they are 1%. So at 1%, yeah, because I got the gold ring on them. Yeah, so they're 1%. Anyways, so they are they get me within that 2450 basically ohm range, so I can test it. Additional resources. This is very good information. He's done a lot of testing with capacitors and not with capacitors. And the this website, this guy has gone through and demonstrated the difference, the SWR difference, and with a capacitor in versus not a capacitor in there. And you kind of will have an idea here in the next slide. So here is one of his charts. So this is SWR with no capacitor. So there was no capacitor put in there. So it's basically just a ground lug to ground lug and no capacitor. So don't be fooled. Over here on this side is the SWR, and on this side is the dB loss. So I think Wayne and Bill were on when I was kind of showing this, but I kind of got backwards on it. But so here's your SWR at 20 meters is actually 1.7. And if you look down here, it even, and this is without a capacitor, mind you. So as you can see, the SWR does kind of creep up quite a bit as you go along here. So with no capacitor, this is what I was saying is when it starts getting up into the higher bands here, we start running into, or the higher frequencies, we start running into where the SWR starts climbing. And this is what the capacitor is actually doing, is just trying to bring that down. So I didn't know, he didn't really have a good chart for me to show, but here is a better chart. So at 10 meters with no capacitor, 1/2 wave SWR was 1.26. With a capacitor, it's 1.41. And it's really, I had better than that, but that's, this is a harmonic. So basically you're just putting that full length of 40-meter wire out there. And so this is the physical harmonics of it. So it's not even trimmed at any point. And I'll talk about the different types of wires that you can actually hook up to this transformer to get it a lot better in performance. So no capacitor, again with capacitor, but as you start getting up in here, no capacitor, 1.3. And this is kind of a really weird numbers that I now that I look at it going, this is not what I was seeing. And basically I was seeing the flip-flop of these numbers on my analyzer. So and you can go, and like I said, go back to this website here, and he has more graphs that you can look at. This one kind of gives you a little bit other detailed information on building the antenna. And of course, this is the toroids information, so you can get information on the toroid. I know that there was a question is how do you know what kind of toroid you have, because they're not labeled. I have not done any research on it yet. I've been busy trying to get this put together. So it'll be interesting to see how we could tell. So basically what the capacitor does is it flattens this down and brings the SWR down. And at the same time as it brings the SWR down, the return loss will actually go up a little bit. But this is still, and when I get down to it, is it still comes back to is it still performs just like a standard half wave dipole center fed. Oops, I got some other notes here. So the primary winding capacitor is not needed for the end fed that operate in a single half wave for 20 meters and below. For 15 meters and above, the capacitor should be considered insertion loss to decrease for the transformer and the primary winding. So basically it'll help, you know, when you hit that certain point, it'll help you out. Capacitor across the primary is recommended for end-fed antennas operating at multi half wave harmonics, and I'll talk about that. The capacitor significantly improves minimum SWR and 2-to-1 SWR bandwidth too. So it basically keeps it down below the 2-to-1 either way. Sometimes then this is where I opted with you know, basically doing 110 picofarad, but there is flattening of the SWR curve above 20 meters is significant, with the largest effect at 10 meters with a 10 picofarad capacitor. So there have been there are people who have actually built this with a variable capacitor and made the adjustment on the capacitor to actually bring the SWR down. So there is something to that if you want to put a variable capacitor in there where you want to adjust it and bring your SWR down. So antenna wise, you have the transformer. Now you have multiple choices you can put off this transformer box. You can just do a long wire up to the highest band that you want to operate and use frequency harmonics. That's pretty much it. Just throw a long wire up there to the highest you want to go and tune it for that, and then the harmonics start falling in place. The other one is a long wire band with band traps. You can also you can do band traps in there that will help. So it'll actually bring your SWR even closer to where you want to operate. There's also a long wire with an 80-meter band trap using harmonics on the lower band. So again, it's just depending on how you want to operate or how you built it. What I've done for my POTA is a long wire with band connectors. So when I talk about band connectors, is basically I have the wire out there and I connect a wire on for each band, and I tune it, then add another band, tune it, add another band, tune it, and then when I want to work on a particular band, is I just take the spade connector and separate them, and I am at that frequency that I'm have the lowest SWR, and the highest SWR I believe I had was actually 1.6, and that was on I don't remember what that was on, but that's, so I have the option that I can actually take my antenna down and just change bands by just disconnecting and get them a little bit closer to tuned frequency, is what I'm trying to say. So here is, I kind of stole this information from M0TW, I believe it is. And so it is based on European frequencies. So I kind of took his formula and I just went in here and did it for the United States frequencies. And so I've separated out from phone band, and I've also, and this basically gives you what the center frequency is. So this is where I tuned the wires to the center frequency. And these are the rough estimate lengths of wire. And then once you get it tuned, so you know what you're putting on or adding on to it to gain that frequency. Then here's the digital, and here's the center. And if you look, there really isn't a lot of change in length of wire, but it just kind of moves the spot of where it's more resident on the antenna. So, you know, if you want to just operate on harmonics, put out 131.83 feet of wire, and you can work then rely on the harmonics of this transformer anywhere. Don't try 6 meters. I tried it and it was an ultimate failure. 10 meters is about the best that this will do. 6 meters I think is too short and gets it. You run into issues where the transformer and what the impedance of the wire are not within what the transformer is designed for. That's what I'm trying to say. But I have it in here just to kind of give an idea and start my calculations off for 10 meters. So the antenna that I actually just built to go on here, to go off my POTA rig, actually only goes up to 40 meters. So it's 66.27, roughly 66 feet in length. But I have connectors in between there, so I can actually change bands pretty quickly by just disconnecting. So this antenna has multiple configurations, and it operates in all of them and does a really good job. In fact, rumor has it, from the material I've been seeing, inverted L's seem to be the most effective radiation off of this antenna. But you can do it in an inverted V. You can do it in inverted L. You can also do it as a sloper, and it still functions just as well. As a sloper, you've got all kinds of different radiation patterns, but what they have found is I'm going to get to the next one, is the grounding. So we have a grounding lug on there, and you should probably, the only thing that the grounding lug does is gives it more of a definitive earth ground. You can put radials up the yazoo under this antenna and it will not affect it. It will not change it. The only thing that I found was is if I put the box closer to the ground, the SWR went up a little bit. But if I kept it a foot off the ground, and if I just put a ground, just a simple grounding wire and stick it into the ground, it didn't change it. But it does help the radiation pattern a little bit during transmitting. So I haven't tested it to be specific on grounded or not grounded for transmitting, but the SOTA has, and when they're doing QRP, they don't normally ground because there's nothing to ground to. They're usually on top of a rock. So they can throw that antenna up there. They put it on over brushes and things like that. And if they're above the tree line, they may have hopefully a hiking stick that collapses, which is kind of what I'm waiting for. I have a 10-meter hiking or a fishing pole that goes down into a hiking stick that I can erect and set up my antenna out of the POTA site. So, but the biggest thing that the ground does, it provides lightning protection, and it gives it a little bit more substantial connection to the earth ground, and it may affect. That's kind of what the antenna analyzers are saying, but I have not seen anything specific to that. Or I shouldn't say analyzers, the modeling, antenna modeling. Here in the next video is another video of Steve doing a field effect difference between a dipole and the antenna itself.
Hello, this is Steve N4LQ. Today we're going to run some tests and compare the field strength of two antennas. One antenna is a typical center-fed dipole configured as an inverted V, and the other antenna is an end-fed half-wave. The antennas are actually the same antenna, and we're just going to reconfigure them to be what I said they were. So this is the station. We've got about 10 watts feeding through an antenna tuner here, and we have used the MFJ analyzer here to get the antenna cut exactly to resonance, and we have resonance. We have 50 ohms, and everything looks perfect. And we're running it through the tuner. We haven't tried it with the end-fed half-wave yet, and if there's any adjustments to be made, we can do it with the tuner instead of actually changing the wire length. The tuner has got its own power meter and SWR meter, which are fine, but this bar graph meter is much more sensitive, and I can tell the slightest difference. So we'll key the transmitter, and it shows just a tad over 10 watts, but I'm looking at these squares on the bar graph and just barely turning the knob can make a significant difference. So I am leaving it at 3 bars, 3 segments there that are lit up. And so now we're going to go out to the antenna and take a look. This is RG8X. There's about, I think, 75 feet going out here. And so here's the antenna. And we've got a push-up mast. It is about 1/4 of a wavelength up. We've got a DX Engineering 1-to-1 balun at the top, and about 16 feet of wire on each side, comprising the inverted V. So we're ready to configure it as an end-fed when the time comes. We'll just simply go up on that pole.
He's using a my antenna, which is basically the same build as this. So you could actually go and buy this antenna. I think it's like $260. Or you can build it yourself and have the enjoyment of building it.
Get up there, lower the pole, short the dipole together in the center, and then we'll hook this wire to here. So let's go over here to our field strength meter, which is way over here. And it's a Corsair 2. And it's running on a battery. There's nothing going to it, no wires, no ground. We have an antenna about 1 foot long. So we're going to hook that up, and we immediately hear the signal. All right. Now I'm going to set this at S. I'll set it for, let me get this set just right. S7. All right. It's set on S7. So there's the field strength with the dipole. So I'll disconnect the power. Got that rag on there to keep the sun off. All right, so now we're going to go we're going to go out here. We're going to lower the pole. We're going to short the 2 wires out at the top, take it loose from the ballon, take the coax loose, and run it over to the EFHW 8010. All right, we're back, and we're setting, and we've got our antenna tuner exactly perfect. 3 bars, a little more than 10 watts right there. Let's go out here and look at our antenna. Then we'll check the field strength. It's a hot day here in North Carolina. Well, here we are. Now this is grounded to an 8-foot ground rod. There's our coax. There's our antenna connection. And right up there at the top, we had alligator clips on each end of this center wires. They're connected together and taped up to the top, disconnected from the ballon. About 75 feet of coax laying on the ground. It's going pretty much at a right angle from the pole, and then it goes on into the shack. And let's go out here and take a look at our meter. Sunny out here, but it's reading exactly S7. No change whatsoever. So what that means is that there's no difference in the amount of radiation from either antenna. Comforting thought. Disconnect the power. So all that fear of losing power in the ground and not having radials, etc., is put away. So you can feed it either way. Now, the advantage here is that I can operate this on harmonics and still have a low SWR. Plus, the access point to the feeder is down at the ground, easier to get to. So that way you can put it close to the house or something. So we've proven beyond any doubt that the in-fed half-wave and the half-wave dipole are the same. We already know from using EasyNet that the radiation pattern is exactly the same on the fundamental frequency. And again, this was on 14.111 megahertz. And there you are. It's about 90 degrees here. And it's been a lot of fun doing this, but appreciate everybody watching it. I hope it's helpful. 73.
All right. So that's pretty much it. Oops, there we go.
Hello, this
That's
is
the end. I don't know if anybody has any questions.
I had 3 questions.
Yep.
Okay. The first one is, if I run my antenna like an inverted L and run up over, will the tower affect it, or will tower help radiate it, or what effect did the tower have?
Yes, the tower will affect it. And it basically, the effect that it has on it, from what I have seen, because I had the same kind of concern because of what we talked about before, it changes the radiation pattern more than anything, especially if you put it, if you hang it in a inverted L and then you put a standoff that keeps it like 2 feet away, it still changes the radiation pattern. So I don't know how much it changes, but if you do a sloper, and you put a long enough wire on it, I think you could probably get it a little bit farther away too from the tower, and it shouldn't have as much effect. I don't know. Anybody else have a opinion on that one? Go ahead, Wayne.
I've tried a sloper. I mean, not with a long wire, but I've tried a halfway dipole with a sloper. And basically I had it, actually not a sloper, it was at an inverted L. And I had the center up in a tree, and then I was coming straight down to the ground, and that's where I fed. And then basically going off at an angle. I mean, I was fed at the center, but one end came all the way to the ground, the other went straight out. And I had this is a 40-meter antenna. I moved that very same one over to my tower, and it affected it greatly as far as the SWR and as far as actual operation.
Yeah, and it would be interesting to see if you did an end fed, because as you see, the ground does not really have any effect on the SWR. And if it's grounded to that tower, it should not have any effect other than the pattern changing. That's kind of what I'm wondering. That'd be a good experiment.
Oh, I think it'd be an excellent experiment. And I mean, mine was center fed. So basically it did have an effect because of the metal tower. But if it's an end fed, it just may not have any effect at all, or just very minor.
Okay, the other question.
So Wayne, to
you
answer
got
your
the plastic
question,
box.
we don't really know exactly what the
Yeah.
effect will be. You're gonna have to experiment.
Yeah.
Yeah,
I figured it had effect, but I didn't know how much. Go ahead, Wayne.
Oh, the thing that
The other question I had.
is that it can be used in inverted V, inverted L, or a sloper, and all three, I mean, in any ration. And I would say that your takeoff angle is going to be different. I mean, all for the different ways you're doing it, and it's going to be possibly a very excellent antenna.
Yeah, and being that you have the options to do it, and it also depends on how you design your wire. I mean, if you design your wire at where you got choke traps in there, or you've got or you just use harmonics, or if you just do an individual wire connect and disconnect, it's all plays into the game there.
The thing I'm very impressed with is that this is, I mean, you can use it as a resonant antenna, because I'm just showing that it is equivalent to a dipole. Now, harmonics, depending upon which you're using it on, they're not quite exactly the same. I mean, you got an 80-meter resonant antenna. It's not really at the right place in the 40-meter band, but I don't know if it's a 70-meter band or a couple of the others, they fall in place, and then you're in good shape. And I mean, it's strange. I mean, it'll work, but not at the best.
Yeah, you're right. And but I think, and to be honest with you, I think, to what you were talking about last week is the receiving side of the things, how much it would be affected on that, especially when you're dealing with harmonics. So
I'm very curious when you get this fully operational and you're doing the testing to see just, I mean, how it really is. And you have a 75-meter tuned antenna, don't you?
Yes.
No, actually, or Wayne does.
I do.
Okay, because basically you can use that and as that as a comparison against this antenna and see what the difference is for receiving and how well it is. I mean, that's the question I'm wondering about. And I guess I don't know. I mean, now with just I'm seeing that, I mean, the radiation pattern and everything, it may be, I mean, when you're in the resonant sweet spot of it, it may be identical the same.
Yeah, there's if you look out on the web, there's actually for my antenna, that one that he was showing there, they actually show a heat pattern. So they actually show where the actual, it's a different graph. It's kind of cool, but it's a heat pattern that shows you the radiation of the antenna and where the bulk of the radiation is coming out of it. It is quite interesting. Wayne, you had another
Okay, I also had a question too. You had a plastic, yeah, you had a plastic box there, you mounted the toroid in. You had a steel box instead of plastic. Will that affect it much?
Yes. Yes, it will. That will, because of the fact that the steel box in itself, and you know, the only reason I say that is I did find that if I took this box here, so here's the assembled box, and I put the testing lugs on it, if I took and put my hands on the outside of it, I can actually change the SWR. That's why you don't want this laying on the ground specifically. You want it at least a foot off the ground, and just just a foot grounding wire to come off the end here to something in the ground is like a perfect measurement. So you just make yourself a foot long grounding rod with a nail in it that you can stick in the ground to kind of give it that grounding rod effect. But yes, I was able to actually do this and change the SWR. Not a lot, but yes.
Well,
and I figure steel would change it a lot more.
You know, Mike,
box.
you know, Mike, when you put your hands on that gizmo, that's called the Wisniewski capacitance.
Yeah, no kidding. It's
Something
all
that
the
we
water
noted-
in my fat.
Something that we noted out at Moonstone Park when we were doing that off-center fed dipole that Valad had. I don't know, it had a different name, but we found we had to have the balun off the ground. We could not leave the balun sitting on the ground. It created a big problem. And I mean, I wasn't aware of that until that time. And sure enough, I mean, it makes a big difference.
Yeah, you don't realize it. And it's one of those things is if I raise it any higher, it doesn't really make an effect, but a foot off the ground. So, I mean, it's not that hard to put a transformer up a foot off the ground. So, but yeah, I would say a metal box would definitely be an issue.
As I recall, out at Runestone, Wayne used the 5-gallon treatment on raising that balun.
Yeah, the 5-gallon tub, right?
Yeah, 5-gallon pail.
And you know, when
Okay.
I cut that long wire, well, go ahead, Wayne.
That's for one.
Oops, you cut out.
Wait.
There we go.
Could
Yeah.
I put a coil wire in the bottom to simulate and then burn my inverter off of that?
I don't quite understand the question.
Inverter L, it's a half wave. I don't
Right.
physically have enough room to run a half wave. But if I put a coil on, run the inverter L off that coil, that would lengthen the antenna.
Oh,
But,
yeah, yeah, you could definitely there's plans out there to make so let's say you want to make this an 80-meter antenna, but you want the harmonics on the other frequencies. Is like I said, you can do the work off harmonics. You can put a 80-meter trap, and there are plans out there. You just do a little search. You can put an 80-meter trap on the end of it. It'll definitely shorten your antenna up. And in some cases, if you put the traps and the frequencies that you want to work in there, it will shorten it up quite a bit too, because you can if you wanted to say 10 and 15 and 30, depending on which frequencies you want to actually work on, you can add those traps in there. There is, and I did see something, there was, don't hold me to it. I think I saw there was like 2 to 5 dB loss with the traps, but I might be wrong on that. I think but there was some loss. And as we all know, when you start shortening things up, you kind of do get a little bit of that loss, but there's people using it successfully. So
What's
because
the
they don't
old,
have the real estate.
what's
Say
the
again?
old rule? What's the old rule? 3 dB is about 1 S unit? Or is it 6 dB? I think it's 3.
Yeah, there is a rule of thumb, and I just saw it the other day. Is it 3? Okay.
Because your dB is a voltage. The dB is in voltage, and 6 dB is 6 dB voltage is 3 dB power.
Okay. Okay. So, yeah. So I mean, yeah, you could still do it and still have the ability to you're just kind of reducing a little bit of your receiving and your transmitting power just a little bit, but all in all, as you saw from the field effect test that he did, it's very on par with a tuned dipole.
Yeah,
You bet.
for
Hey,
me to put
thank-
anything up in the air and over again, I need to be next to a tower. I don't have any tall trees here.
Yeah.
That's what I
Well,
think about next for.
you could put a standoff with a pulley on it, couldn't you?
Yeah. That's what I would do. It'd be like 3 feet away from the tower. But
Yeah.
3 feet at 160 is not very far.
No. But if you realize that at 160, that if you put, I would say, more than half on the top vertical, your radiation will be more out that anyways, because remember, you're moving your voltage and your current to that center. If you move that out farther and don't have as much of the vertical line, I would assume, I mean, correct me if I'm wrong, I would assume it would be a little bit better in radiation pattern. Be more of a vertical takeoff.
Okay.
Thank you, Mike. Great presentation.
Excellent,
I hope
Mike.
so. I worked on it. I just, there's so much to this that it's capable of doing, and it's like, where do you cut it off?
I'm looking forward to seeing that in operation, Mike.
Yeah, I am too, because I'm still waiting for my, like I said, that 10-meter fish pole that I want to just fling that up and then see what the how well it will perform, because I got my backpack, my 706 bioanio battery, everything's ready to go. I just want to get out to a park, and there's a Birch Park State Park out here, so I want to activate it. It's only been activated once, and since POTA has been going. So
Is that out on Big Birch Lake?
yeah, it's so there's a road on the it'll be on the Stearns County side.
Yeah,
I think you've seen that. You've seen the sign, I'm sure.
I've been in
I
there.
think, Mike, you can get there by boat.
You're right.
On your side of the lake and then come all the way across. So they got a beautiful boat landing.
They
Well,
do.
say that again, Bill.
They got a great boat landing there with a pier as well, but I've been out there hundreds of times. It's the Big Birch Lake State Forest area.
State Forest, that's right. Yep.
Yeah.
Yeah, so, and I saw there's that road that comes in, and I saw there was kind of like a big area, open area that I could set up in, that I figure, but like I said, the biggest thing is deployment and demob. How fast can I set it up? How fast can I take it down?
Yeah, they've got a large area out there for group camping. You could go in there. They also have a picnic area and then the boat landing area itself. So you got a couple of choices.
Yep, and I got my state park stamp, so I should be good.
You don't even need that.
You don't even need it for that one.
Free
Nope.
admission.
Oh. Okay.
But the facilities are somewhat primitive.
Oh, I don't know. I've got to have a bling toilet seat and everything heated.
You'll probably be questioned by the camp manager Because they have some guys, some older couple that manage it throughout the summer for camping.
Yeah, it'd be a good idea to get his permission, I suppose.
Yep. Yeah,
Can I-
so
May I quit recording?
you can.